Well, there has been talk about the DTA. Why am I talking about it? I don't even remember how it got started, but I got in touch somehow with John Gow when working at Menzies. That always put me in a good spot to pick up the phone and say, hey, OS2. Oh, you know, work with OS2, you know, that IBM for it actually, this whole thing. This is one of the documentations from the INF files from IBM, how the complete multimedia subsystem of OS2 is structured. The basic reason for including this is that it was actually, I think, one of the most, at the time, well-defined architects for multimedia. It had codecs installed, it had a standardized structure, it had Dive, which this was basically a kind of predecessor for DirectX. When we were still playing around with Windows 3.1, this all existed in Warp 3, which was way ahead of its time with sync. Probably everybody remembers this software motion video demo that David Barnes did with NT versus OS2 shootout with two software motion videos running in sync. That all has to do with it. What does it have to do with the DTA that provides audio in WinOS2 and DOS? A lot. I'll explain to you why. Basically, when you have a device driver under, this is basically what happened when hardware vendors were still making support for Windows 3.1. In OS2, you have a PDD, which is the physical device driver that talks to the hardware. So when OS2 wants to play a sound file, MMOS2 talks to that audio device and that talks to the hardware. You've got that loaded as a sys file in your configs, just like UniAut. Then on top of it, there's a VDD, which is a virtual device driver, which runs into the DOS and Windows 3.1 application. Now, normally what they used to do is that they would provide some support that the normal Windows 3.1 audio driver could load under OS2. The VDD would basically be a traffic cop, and when WinOS2 wants to access the hardware, it would block access from OS2, and that's how it worked. But the problem was IBM had contractual obligations to provide Windows 3.1 audio support, even when customers were not using it. These were long-standing maintenance contracts. So when the Windows 3.1 device driver audio development was phased out, what do you do? So they started working on something, and you can still find the remnants of that in the DDK. There is something in there which is actually, I think, called the generic WinOS2 driver. Now, what it does, and this kind of goes back to this chart, and it's a bit technical, but I'll cut to the chase. In OS2, just like in any other protected operating system, you've got ring 0. That's where the kernel is running, UniAut, your storage drivers. And then on ring 3, you've got your applications like the browser, etc. If data wants to travel, audio driver that was included as a proof of concept went from WinOS2, it went down via the device driver to ring 0, then it looped back into OS2, and then the audio from WinOS2 was sent in via Dart. Dart is an audio interface in MMOS2. So what it would do, it was a bit like a slalom. It went from ring 3 to ring 0, and then it went again from ring 3 down to the audio driver. And at the path itself, it goes from Dart to MMOS2 to, oh sorry, it's actually, what's the name of the driver? Sorry, this is not called ours, this is not ring 0s. Anybody ever noticed in its configs of OS2 a weird device driver called R0stub.sys? That driver is a device driver that is hooked up between MMOS2 and the actual audio driver. That's where the audio buffers are relayed over from. Anyway, the thing with this whole data path is that it takes time. So if you would hear a startup sound from WinOS2, you would hear it, ta-da, and it worked. The soon that you start to play audio files or a game, This whole ring transition, this back and forth of copying these data buffers, slowed it that far down that it started stuttering because it couldn't deliver the audio drivers in a timely fashion to the audio driver. So actually what DTA is that it cuts out the bureaucracy. It throws it all overboard. And basically what DTA does is that there is a sys driver that loads in the config sys, and there's a little daemon that is loaded. And the moment that you start up Windows 2 via Dart, it blocks the audio driver in MMOS2 so that not somebody else can access it. DTA.sys then talks directly to the audio driver, bypassing MMOS2 completely. What's the use of it? It's high performance, because basically an audio buffer can be sent directly to the audio driver, bypassing MMOS2 without breaking it. And this is why this DTA is useful for WinOS2 and DOS sessions. I have a laptop here on which the DTA is installed. And basically there's a device driver in Windows 3.1 and it's 1600 bytes. It's nothing else than a stub driver that the WinOS2 API can talk to, installed in the VDD, in the DOS VDM, and sends the audio drivers directly to the audio driver. All of this stuff has been developed circa 2005. It was included in Ecom Station, and ever since this has been kind of lying dormant. Now, you have heard that discussion before. Martin Kiewitz, who was an advocate gamer at the time, who built a whole bunch of patches, started developing something called vSound. And now we get, is this the prop? Yes. Here you kind of have an idea what the architecture is. You've got DTA.sys, and here you have the VDM. This is what we're interested in. So you have the WinOS2 support, and you've got the DOS support. Now WinOS2 is basically working. Audio support works, and because this direct access to the audio driver on OS2 level is there, you can play any Windows 3.1 game without the audio breaking up. The thing that everybody's interested in is the Soundblaster support. But just like with the video support under UEFI, getting DOS games to work is pretty complicated. Does anybody here know the sound card from Gravis, a Canadian company called the Gravis Ultrasound? Guess what killed the card? The Soundblaster emulation. Emulating proper Soundblaster support is pretty tedious. You got to remember that a lot of these games were written on 386, 486 and Pentiums. And the games are extremely sensitive for timing issues. So if now I'll get to this little portion. Op. If a game wants to play an audio sample and it sends it off to an emulated Soundblaster card, it better deliver the data on time to the card. Otherwise you're going to have it moving out of sync or the music moving out of sync. And that's what's making that difficult. The current vSound.sys has Soundblaster support for Soundblaster Pro, Soundblaster 16, and I think also AdLib. It has 3 modes that you can set it to. The only thing that's currently missing is sending the actual audio that it sends to the audio driver so that we can hear it. That's where currently the code is frozen, and that's where we need to pick up on it. Just sticking in a TSR is not going to cut the cake. The problem is the VDM in OS2 is basically a virtual machine. A lot of people don't know it, but 25% of the OS2 kernel file is all code to accommodate the VDM code. So that's for DOS and Windows 2 support. That kind of gives you an idea how much time IBM spent. So if you look in your config sys and you see this thing like the MDOS directory loading Windows 2, and you see this VDMA.sys and these other drivers, that's only a portion of it. It's a much bigger framework of which is all hiding in the kernel. So if you look under the bonnet to get this WinOS2 support, the WinOS2 support is working, but it doesn't have music support. So what's going to be needed, at least that's my perspective on it, is that there is also, John Gow created an updated timer0.sys. In 1996, timer 0, which is a base that was introduced in OS2. Why? It's a high resolution timer that was specifically created for multimedia applications that need a high frequency timer, or for example for MIDI input. It's still there, it's just one problem. Only one program can access it at the same time. So if an OS2 program is using it, it's locked out. So there's an updated version of timer 0 available that enables it to share it. So that's the first change that's to be made. The other thing is, and this is where you get into the VDM details, there's a driver in OS2 called vdma.sys, which is a virtual DMA controller. And if there's one thing that you probably remember from all of these DOS games, is that you could set your Soundblaster to, for example, DMA 1 or 3, or hex address 220. So there also needs to be possibly an updated vdm.sys inserted, because again, the problem with a lot of these DOS games is that they're extremely timing sensitive. So if it's not able to deliver its audio on time, your game will start running behind. So we're pretty far as a community. We have sources, but somebody needs to sit down and get it to work. But it gets more complicated, because that's just the sound. What about the music? Well, as you now understand, the data transport agent talks to UniAuth. Now this recently has changed, but best I'm aware of, UniAuth still only supports one active audio channel, and all of the MIDI support has disappeared. So what needs to happen probably is that in vSound this needs to be added for the DOS support, meaning that when you have an OPL3 game with these bleep sounds, remember the music, that has to be emulated and then mixed with the audio and then sent to the DTA.sys. And then you move towards something of a workable sound solution. That's how much is engaged with potentially getting something working. So we have a framework for that. Oh. We have a framework for that, but still a couple of, so the foundations are there. WinOS2 is working more or less. Most applications are working, but just the DOS support, just like with VEFI.sys. Remember, this is a complete software emulation. It's just a bit like DOSBox. So this vSound.sys, when an application talks to it, it thinks it's talking to a real audio card. That's why the whole data path to the audio driver has to be quick and working in a timely fashion and correct. And that's what all of these DOS games did. They have all sorts of tricks to make it run as quickly as possible. And you probably remember games. Who remembers here a game, for example, like Wacky Wheels? Nah, okay, sorry. When I grew up in my this is what we roughly need. Now, as you probably know, I can't switch to an external screen, but there is a laptop here that that is running WinOS2. If you want to believe me, you can look on the screen here. In fact, what I'll do is I'll just start WinOS2 again. There you go. And now I was looking for some kind of a game before I came from Holland to bring with me with Windows 3.1 that plays QuickTime movies in it, etc. That works. So that plays a movie, and I think even video for Windows works. And you can play, for example, use an old encyclopedia in WinOS2 and the audio playback works. Now one of the things is that I just actually tried it, so I don't know if I can hear it. I'm now using the WinOS2 audio recorder, and it's recording. So now it's actually recording via the via WinOS2 and recording the data to disk. So if I now turn it off, so this proves the concept that basically that's the whole reason that this thing got developed in the first place. You can have audio support without talking to the hardware directly, and that's the whole concept of the DTA. Now in the near future, depending on what happens, this also could be used for MMOs2 or other applications, but the first goal is to get the DOS support working. And that's something that Arcano has to find a developer for, because debugging VDM code, debugging the kernel is, you know that debugging the kernel is one thing, but getting inside the VDM code is yet another step higher, to heaven or hell, whatever you want to refer to it, because it's even more complicated, because the VDM code is basically something that kind of, it's its own subsystem. You probably heard Steve say that more often about VDM code, that debugging that, Greg, is not the biggest slice of cake. So, well, I'd just like to give you another, sorry if just like my UEFI presentation, this all went completely under the bonnet of the engine, how it's working, but this is what it's going to take. So we have building blocks for it. There's a lot of code that's around. It just needs to be put onto a pile, and the remaining strings need to be tied up. And current estimate, I think 3 or 4 months. Because, and this is what I known from my Gravis Ultrasound days, that's why I mentioned it, the graphics card got killed because of the lacking WinOS2 support. They had a whole iteration of these Soundblaster emulators that got loaded, and still all sorts of games wouldn't work. That's the difficult part with getting real proper sound. And when somebody plays a legacy game, they basically expect to press a button and that the music and that the sound is in sync with the game. Not that you're running behind it at the end of the game, that the music is running 20 seconds behind, for example. So I hope you find it somewhat interesting. If you do have WinOS2 applications that you want to use, the current DTA is on hops, this version. It's not perfect, but at the time we put it in Ecom Station because it was at least the only way out for people wanting to have a form of Windows 3.1 support. The DOS support is non-existent. There are compiled versions of the driver floating around, but it doesn't relay the wave audio of the game to the DTA, so that's why you won't hear anything. So I hope I didn't fry your brains on this Saturday morning. But I hope you found this informative. Are there any questions?
This could work with other sound drivers.
It's sound card independent, because it talks at the bottom, it talks directly to the audio PDD of UniAuth. But this could be made to work with any audio driver for OS2. But since UniAuth is the only predominant driver available, you know, I know that in ArcOS there are a couple of drivers for older chipsets, but you know, 99.99% of the installations refer to UniAuth.
What about USB audio?
Should work. It's a standard audio driver, so if, I think that would be a cool, that would be real nerdiness, playing Windows 3.1 games via USB audio speaker. That's
the future. You know,
so
UniAuth is, you know,
UniAuth is not dated. No, I got to protest against that completely. UniAuth is in sync with the latest ALSA sources.
But even on Linux, you know, ALSA, where is it going? You know,
ALSA? Well, is ALSA deprecated on Linux or something like that?
Well, the audio support is moving into the kernel in Linux.
Oh,
so
okay, that I didn't know, sorry.
The ALSA driver is essentially what's been extracted from the, or abstracted, I should say, from the Linux kernel.
Oh,
so I understand.
okay.
That's why we're talking about We don't talk about it in terms of the ALSA version, we talk about it in terms of the Linux kernel version.
Okay, I didn't know, yeah. That's the same thing where when I worked at, look, everybody has been asking for Wi-Fi drivers. And when I worked at Mensis, we already started on this journey. But we basically on Linux got bitten by what now happened on FreeBSD. It's basically a copy of it. They changed kernel structures. That has bitten us. Thank goodness, at least, Paul Smedley and David have been working relentlessly to keep UniAuth up to date with the current. That's what I mean, as far as I can tell, the current UniAuth is pretty much in sync with what we currently have on Linux, making most systems working.
The latest build from Paul has some compatibility issues with older hardware. So, for instance, I can't run it on the T43; it locks up the T43. And not just hardware that old, but slightly newer than that also.
Okay. Yeah.
But the biggest issue with UniAuth is getting the mixer support right, because we can recognize a particular audio chip, but then the mixer gets misidentified and you don't hear anything. And everyone says UniAuth's not working. No, UniAuth is working fine. It's just looking for a mixer that's not there.
Or use the gruesome, I find the Unimix command line a house of horror, but maybe that's me personally. I don't find it that intuitive, but that's me. So, are there any other questions? So, exception, it won't work with an old Soundblaster 16 or AW32 card. But you know, if you are at that level, just stick with the native Soundblaster card. It uses some kind of special technology used in MMOs to why the DTA does not work. But all other sound drivers, including a USB speaker, will work as well. So it's completely transparent. It's completely independent of any driver. Are there any other questions?
So my other question was, you said that it's speaking directly to the hardware driver bypassing MMOS2.
Yes.
So how do you avoid that like a collision between the OS2?
There's a daemon in place, and the moment that a VDM accesses the VDM accesses the audio card, there's a little daemon that acts as a native OS2 program. It steps in and it blocks it via Dart. So it opens up the audio driver under OS2, effectively blocking it from OS2.
So if OS2 tries to access it, will you get that crazy dialogue of, oh no, I can't access the sound? Or
yes. Because that was also the point with the music emulation. We have something like timidity. But the point with timidity is that it needs another audio channel. And best I can tell, the current UniAuth, if you have an HDA audio chipset, it supports up to 4 different simultaneous channels. Now, I did understand that David recently said that he got system sounds and playing MP3 files working. I seem to recall that he said that.
I don't remember.
So, but but at the current moment, so that's why getting this to work with both music and audio simultaneously, something with the current setup has to be done in vsound.sys. Now, probably the cheapest thing to do is to hijack the code from DOSBox or something of an equivalent and put it in there. The drivers are GPL anyway, so you know, that will probably stay a GPL project. If there are other solutions to do this, I invite people to look at the README file of it, and you'll see that it's a gruesome task to get DOS games to work properly. I'm willing to place bet $1 on it, that if you start looking at DOSBox, that there is an endless list of all DOS games where they had to implement quirks and workarounds to get it to work properly. And the thing is, on OS2 we want to avoid that because we've got only very limited resources. And talking about resource, you have another question? You said you had multiple?
No, those are
okay.
two.
Are there any other questions? Because we're running out of another resource, and I think that's time. And I think some people might start to get hungry now, so. Okay, well, I hope you found it somewhat insightful. Again, maybe a bit too deep going under the bonnet how this all works. But this is what's involved with keeping OS2 running. We need people to really look under the hood and to work there. You know, that's what 5.1 shows it again. It has been a tremendous long journey. You can see this laptop, and Alex's laptop that's running in UEFI. So, you know, this stuff, it's possible. Thank you for your time, and I'll see you tomorrow about the browser.